All right, let's look at the slope of a tangent line, alternative definition. All right, so remember that the slope of the tangent line to the graph of f of x at a is defined as m equals limit of f of a plus h minus f of a over h as h approaches 0. All right, there's an alternative definition. The process is exactly the same. Here, let's say you have a graph of a function here, and let's say a is probably right around there, right? So this is a right there. All right, then we want to find the slope of the tangent line at that point. So the slope of tangent line should probably look something like that. All right, so this is the tangent line, all right? Then what we did before was we're going to look at the secant line, and which has the second point, and we move the second point closer to the first point. We're going to do the same thing here. So we have here, right? Just the labeling is a little bit different. So I'm going to say this is going to be our x, right? Then I'm going to move this point closer to the point, first point there. All right. So the secant line is going to look, let's see, maybe I'll use a blue. So this is a secant line. All right. Let's find the slope of the secant line. All right. So this is just going to be rise over run. So let's try to find the rise. So this point, the corresponding y value is f of a. All right, and up here, since x value is x, corresponding value is f of x. All right, so what you can do is when you have a secant line, and the slope of the secant line can be found by doing this. All right, so slope of the secant line would be, rise is difference between f of x and f of a. And the run is the difference between x and a. All right. Then what we want to do is, so that's the slope of the secant line. We're going to try to mimic the tangent line by putting the second point closer to the first point. How do we do that? What we do is we want to send x value. So you have an x value here, and get closer to a. All right, we know how to write that, right? So this is going to be, all right, so you want to take the limit. All right, the difference quotient is f of x minus f of a all over x minus a. So we have that. Then we let x approach a. All right. So this is the alternative definition of the slope of a tangent line. All right. Let's use that to find the slope of the tangent line. So here's an example. Let's say you have a function f of x is equal to square root of x, and let's say a is at is 3. All right. So let's find the slope. All right. Slope of the tangent line m is equal to, all right, you have a limit as x approaches a, in this case 3, and f of x is square root of x, minus f of a, f of 3 is square root of 3. And then we have x minus a, which is that. All right, so let's compute that. All right, so as you can see, as x approaches 3, denominator goes to 0 and the numerator goes to 0. So we're going to have to use a trick. So the trick was we multiply top and bottom by square root of x plus square root of 3. And same thing to the bottom. So you have x plus square root of 3. All right. And then what you get is going to be, let's multiply it out. So you have a limit as x approaches 3, right? And since we have a minus b times a plus b, so you have a squared minus b squared. So a is a square root of x, so a square would be x, minus square root of 3 square would be just 3, right? Denominator, luckily we have quantity x minus 3 is sitting here. And then you have to multiply by square root of x plus square root of 3, right? But you can see that now we have a common factor on top and the bottom. So we have 1 left over, right? So in this case, x is going to 3. So this guy is approaching 3. So what you get is going to be this 1 on top. And then you have a square root of 3 plus square root of 3. So you have 2 of them. So you have a 2 square root of 3, right? So this is the slope of the tangent line to the graph of f of x, which is square root of x, at x equals 3. All right, that's it. I hope that this was clear.